for a solution to this equation, ordered pair solution. Now y'all, by the natural numbers, I do mean z plus. Okay, z plus, positive integers, right? So z plus, and we're looking for a single ordered pair, just a single ordered pair. Now the algebra here is fairly routine. We leverage the difference of two squares right here. Notice right here that this part right here is computationally very effective. This piece is 2, which is exactly the 2 that you see right down here. Okay, and so I won't say much about the algebra. It's fairly routine. The difference of two squares formula makes the math a little bit easier. Now we're at this stage where we know that 8's in the numerator, but we have this monster of a number in the denominator. Now with some effort, you can show that this part right here is 8 over 2 squared. And again, this was a little tedious, but the factorization of this almost prime number is 43 times 47. Now I'll justify that just a little bit, and I know I'm just writing it down like, oh, you're supposed to know. No, it took some time. Now, so there's a well-known result from number theory that says all you have to do is check the square root of the number and check for prime divisors. Well, it turns out 43 was the last one. It's not surprising because you can see that 47, 7 times 3 is the one that you get right there. So the very last prime in the list actually worked. So I guess you could call this number almost prime in some sense. Okay, so we're looking pretty good right now because now we have a smaller set of numbers to check. Now what I've done, I've constructed a little table down here for y'all just to keep me organized as much as anything. So we need y minus x to equal to 8, right? And so I've just gone through and checked all the factors. Now these are obvious, almost didn't have to write them down, right? No, right? I mean, look, come on. 84 minus 1 certainly is not going to be equal to 8. But I just wrote it down to give you an idea of how valuable the prime factorization is. Now let's move along here and see if we can spot some factors to get the job done. You'll notice the ones I've gone through and done these first ones here, there's no way they're going to work out. But notice that if we split the 2 up, in other words, let me just write this down for you and quit talking. 2 times 43, pair it up with 2, okay? It's nice. You don't really have to know what the numbers are. You just have to know the prime factors, and also pair that up with 2 times 47. Okay. Now you see we cover all of the factors in the prime factorization. See 2 squared gets covered, 43 and 47 gets covered. All right, and so we're in good shape right there. And we caught a break here because 2 times 47 is 94. So we actually get 94 minus 86 equals to 8. All right, which is good news. All right, that's equal to 8. So yippee, we're happy about that. Great. Okay, so we got that to happen. Now, so that means, folks, that our solutions will certainly be x equals to 86, and this is the first coordinate of our ordered pair solution, and then y is equal to what? 94. And that is the ordered pair solution, folks. In other words, we can write it like this if you want to. 86, 94. Yeah, I'm not claiming this is the only solution. I just said find a single positive solution. There are many others. You can actually turn this into a combinatorics exercise and count the number of solutions also. That's another problem that could be asked. But anyway, that is the answer. Let's run up here. So 86, 94 is the solution here. Okay, folks, hope you enjoyed that one.